So we're going to look at one here, and this is going to be an example of how, again, our principle is very straightforward. We define our geometrical relationships, and then we take derivatives. The geometry is not as straightforward on this one. Okay, so when I was kind of practicing this and getting ready to go, I just by default went down the law of cosines road, and that quickly crashed and burned. So I switched, and I thought, well, let's try law of sines. Okay, so I've got law of sines written up there in the corner, and it corresponds to our angles here inside of our triangle. All right, so alpha, gamma, and of course that guy is theta. I decided to call this side B, as you can see, this side A, and of course this side over here is left as L. Okay, just like that. So I was like fishing around for kind of how to proceed, and I went ahead and found when theta is equal to 45 degrees, what is the value of A, what is the value of B, what is the value of alpha, okay? So I've got those numbers up there. You can see L is 5, A is 1.494, B is 4.082. And then since all my angles equal 180, it's easy to work out the individual values for, the value of alpha is the only one we don't really know there. Okay, so we've got all that. One of the things that's different about this is we don't have a straightforward relationship between our variable of interest and the variables we have to work with, okay? So we know that V sub A is going to be 6, but that's all we know. And so we got to figure out how to relate that to theta, which means we have to relate A to theta, because V sub A is, of course, going to be A dot once we get that worked out. So if we look at our law of sines and cosines stuff, I'm going to move that down here just a little bit because it was behind. Whoops. So in the law of sines, we have sine alpha over A, sine theta over B, sine gamma over L. And there's no straightforward relationship that combines all of our different elements, which means we're going to probably have to take a couple of steps to pull this off. Okay. So let's go fishing for theta dot first, and just see where that leads us. So to go fishing there for theta dot, what I'm going to do is I'm going to focus on this relationship right here. Okay, sine theta is sine gamma over L, and we'll throw a B in there. And in fact, let me go ahead and rewrite that specifically. So we're going to have here that, whoops, it's my highlighter. So that B is going to be, one more time, B onto sine gamma over L is going to be equal to sine theta. So there's my relationship. And I'm going to make that thing just a little bit smaller. Then, just like before, we'll just take derivatives. We'll see what happens. Okay. So the part in parentheses here, this stuff, thankfully is all constant. So we could just leave it lumped together. We don't need to mess around with that. But when we start taking derivatives, then we're going to have B dot, this parenthetical stuff, sine gamma over L, and that has to be equal to cosine theta dot. Okay, so we're looking for the velocity of the roller B. It's one of the things. So that is B dot. All right. The other thing we're looking for is the angular velocity theta dot. So we have one equation and two unknowns. So this is not, it's an okay start, but we've run into a wall. So let's focus on a different part of the relationship. Trying to get rid of that, but it doesn't want to. Okay, so let's focus on this part of the relationship. Skip the middle, just like that. Okay. So let me grab a good color. I'm gonna pick something a little bit darker to work with. So if I write this in the same format, then I'm going to have a, we're going to have A onto sine gamma over L, and that's going to be equal to the sine of alpha, like that. Okay, and let's just take derivatives and we'll see what happens again. Do that, play that game all over again here. So that gives us A dot onto sine gamma over L, and that's going to be equal to cosine alpha dot. Okay. Now we actually do know A dot. They give that to us because that's V sub A, which is 6 feet per second. What we don't know is alpha dot. Okay. All right. So here we are again. We got to figure something out. We need another relationship. Well, that's all we got out of our law of sines. So we need another relationship. And that relationship is this one right up here. Okay. This guy. So let's take derivatives there. Let's just see what happens. Maybe we'll get lucky with something. All right. Oops. All right, so if I start taking derivatives, I get alpha dot plus theta dot plus 0 is equal to 0. And that tells me that alpha dot is negative theta dot. Well, that's kind of weird. Let's think about that for a second. So that really tells us that when one angle is positive, the other changing positive, the other's changing negative. So as this roller thing goes down the wall, the angle theta is getting bigger and the angle alpha is getting smaller. Okay, so good, that works out. So that's why we have that negative there in our relationship. It works out pretty well for us. That is our relationship that we can plug in to what we just did. So we can say that A dot sine gamma over L is equal to cosine alpha minus theta dot, just like that. Okay, and with that, this nut is cracked. All we need to do is plug in our variables that we've already calculated, okay, and then we're good to go. Let me show you. I'm not gonna calculate them, but I'll leave that to you. So we know gamma is 120. We know L, when we know alpha. So all those things are known, and we know A dot is 6. All right, and all we have to do is find theta dot. Once we get theta dot, we can take it and we can run it up here into that equation there. Then that equation, the only unknown is B dot, and then we just run our numbers and we have our answer. Okay. So again, our process has not changed. The process is just about establishing the geometric relationship between our variables, and then we take derivatives. In this case, we end up having to have three different relationships, but it worked out very straightforward once we sort of plugged things in. Okay. Now, I didn't know how to work this one off the bat. Okay. Like I told you, I started with the law of cosines and it went south quickly. So I was just like, okay, well, let's try something different. So I thought, let's try the law of sines. Then I began to see that we had some relationships. And I knew within our triangle, we had some other relationships with the angles, alpha, theta, gamma, that way. Okay. So, like I've said, you try it one way, and if it didn't work out, just try it in a different direction. Okay.